So we're in your biology book, chapter 17, section 2, avian anatomy and physiology. So this is pretty interesting in how the birds are compared to our anatomy and physiology. So of course we're going to start with feathers. So let's go on to the picture of the feather I described. Feather, here we go. Feather in the wings, the types of feathers. So feathers are designed for flight. In fact, every feature of them is designed. It's so specific. Their lightweight and their light body actually has excellent insulation for the feathers. Insulate at keeping their temperatures at 109 to 110 degrees Fahrenheit. They're very smooth and tapered, as you can see, and very streamlined. They have a broad area for the wings to catch the air. And without feathers, these little birds would be pretty useless, wouldn't they? And easily destroyed and predated on. So one thing a bird can do is fly away. So let's look at the types of feathers here. So we have the contour feathers. So you see these contour feathers. This is how they look, these little contour feathers with a smaller feather with a tuft on the end. These are strong on the bird's wing and tail because they streamline. They're very strong feathers, although they're short feathers there. So they keep that contour going. And then we have the flight feathers. And here's the primary flight feathers that catch the air. And here are the secondary flight feathers. And here's the tertiary, these flight feathers. So they have three different kinds of flight feathers. And these give the wing the shape and the contour so it can fly. So here's a flight feather right here, and you can see how they're longer length there, and they're designed for flight. And then we have the small little down feathers, and these feathers are soft and fluffy, and they insulate close to the body so they can keep the temperature the bird at a warm temperature. And plus keep the energy. If a bird would get very cold, its temperature, it's very warm blooded, and so it would get very cold and die. So you need a lot of these down feathers. Remember that birds are warm-blooded animals, homeothermic animals. So let's go on to the next page. We're going to be talking about the feathers here. Actually, there's a little, I want to read this article because I thought it was pretty, you could read along here. It says, according to an ancient Greek myth, Daedalus, an architect and sculptor of Athens, fell out of favor with Minos, king of Crete. He and his son Icarus were imprisoned in a maze called the Labyrinth, but they determined to be free. Daedalus closely studied the wings of the seabirds, and with wax and feathers he made 2 pairs of wings of similar design. Flapping these wings, father and son soared into the air, intending to escape the island of Sicily. Then came the disaster. Icarus, excited with his ability to fly, forgot his father's warning and flew too near the sun. The result, according to the poet, was with melting wax and loosened strings, he sank hapless Icarus on unfaithful wings. Grieving, Daedalus landed safely in Sicily, but Icarus drowned in the Mediterranean. This old myth illustrates the longing of earthbound human beings that have always felt to soar into the sky like the birds. Over 2,000 years after the days of Minos and the legendary Daedalus, man did learn how to fly, but not by attaching wings to his shoulders. Eventually, human beings face the fact that besides having no wings, their bodies are in no way designed for flight. For example, the breast muscles which operate the shoulders and arms in a man constitute less than 1% of his body weight, while those of some birds weigh as much as 33%. So I'm going to go over a couple of these things. You can go on, but I just thought it was very interesting as how even in our history, in our poetry, and those things in our imagination, man has always wanted to fly like the birds. Let's see, watching the birds. And of course we can fly now. We know on planes and how magnificent that is. But here God designed a bird being born with that ability to fly. So let's go. I'm going to go on to this next picture here, because we're going to look at the design here from the previous page here, but here's the picture of it. So designed for flight. Wings of the bird are 33% of their body weight. That's quite a bit. And they have hollow bones and a very rigid skeleton to hold these bones, and so they could be rigid in flight. And they have large, strong hearts that beat a lot of oxygen, stronger hearts than men have. And they have an increased respiratory rate. So they breathe more times per minute to get this oxygen. And they also have a digestive system that provides much energy. They're very aerodynamic, let's just say. And every position of the feather is designed for to extract the energy from the air as it flies efficiently. So every aspect, as you can see, of the feathers and of the bird is designed for this task of flying and making it very efficient. So let's look at this feather here. So here's a feather, the structure of a flight feather. And a feather has 1 million parts. Can you believe that? 1 million small parts. And these parts fall into certain categories. And so we know, as for the categories, we have ratches, I should say. Ratches, and this is the picture of the ratch. So here's the ratch here. They have ratches, they have barbs. The barbs on the ratches are right here. And then they have the vein. We see the vein, several hundred barbs on these veins here. So you see the veins. And the barbules are these tiny that hold the barbs, the barbules. So here's barbules, and they hold the barbs, and they're like little hooks. And these little hooks have at the end called hooks or hamuli, which means hooks. And they work like a zipper. And so this means that when in flight, it puffs out, and then when they come down, they zip up by preening. So they come together, so they're really smooth. And when they fly, they puff. So, and they automatically change, these feathers automatically change in flight. So let's go over that just a little bit more so they can probably be part of your test question. First of all, I also want to say some birds have more feathers. A hen has 8,300 feathers, and a swan has 25,200 feathers. Even though a swan, of course, a swan is bigger. And a hummingbird only has 940 feathers, but it has more feathers per square centimeter on a hummingbird. So these birds, they all have in common feathers, right? So let's look again at, we're going to look again at this feather, and we have the ratchus. This hollow quill comes down, this ratchus, and it has grooves in it. And these grooves are with barbs. See, this is a little picture. This is actually the picture of the ratchus here. So you see with the barb. See how this little part is poking over here, or pointing over here, I mean. And the barbs have these, this is on here, they have these barbs with these little hooks, and these little hooks are called hamuli, which are just mean hook. And then the barbs, and the barbs here, and the barb with the hook. So, and the barbs with the flanges. So you have some barbules with these flanges here, down here as they come, and you can see the barb with the hooks and these barbs, right? Barbs are these filaments on the grooves here of this ratchet. And then of course, then we have the veins coming down this way. So the veins are several hundred barbs per vein. So you have barbs on these veins too. So, so that's a feather. Very complicated, huh? So a feather automatically changes shape in flight. So that means that some are curved, some become curved. As the feather curves, it might straighten out, it gets thick and it gets thin and it gets round and hollow and sometimes even turns like square and many-sided with a flat groove. Depends on the air. So it changes in the air so that it will be able to be aerodynamic and it can fly. So it's pretty amazing. And then we'll go on before, but a lulu means 3 feathers. Some of them have 3 feathered wing slots, and these 3 feathers in one, and that helps and prevents them from stalling in air, and so that they can maneuver in small spaces with these 3 little feathers. They're almost like little helicopter feathers. So especially in a small bird like a hummingbird, you know, it looks like changes its shape so it can hover around, you know. So, or hover around, however you want to say that. So the tail also, let's see if there's another picture here. Here's a picture of the albatross there flying. So gliding in flight. So let's see. I was going to see if I could find another picture here. Here's the hummingbird pattern here. So you see right there with that hummingbird pattern has a figure 8 pattern as its wingtip comes. And so the tail is its rudder there. As you see how the tail comes down in its rudder. Let's go a little closer. There you go. The tail with its rudder, and it increases its elevation and it controls its direction. And some birds have their shorter tail that have a really shorter tail, and a lot of times because they use their webbed feet and the short tail, so their webbed feet kind of acts like a rudder too. So here we have, as for this hummingbird being able to hover around, and that's because of it's in its high, I should say, its high metabolism. So. Also, the nerve endings converted to the feathers to a sensory organ. So the feathers also can be, they can feel in their feathers. And so they can sense how their feathers are acting. And they can position their feathers, and they can have fine adjustments in their feathers. They have 12,000 tiny muscles attached to the bases of their feathers. 12,000 tiny muscles and nerves. They have all these nerves in their feathers. Can you believe that? Pretty amazing. So let's go on to their flight patterns here. See if we can go on. As you can see, this last part is, let's see, their flight patterns. Well, let's go into their flight patterns here. I think I have to go back to the next page for their flight patterns. This whole video is just on their flight patterns. Okay, you can see the different flight patterns. It's kind of important. Ornithologists, I have to say that right. There are the scientists that study birds, and they have 4 different flight patterns that birds fly into, or that's how they fly. When they fly in a pattern. So it's such a masterpiece of nature, and it's too wonderful for chance that each bird would have its own flight pattern too. So like you can say, you take the crow and the blue jay, they're gonna fly different, or the mallard, or the teal, all these, or the eagle and the hummingbird, they all fly different. So let's talk about the flight patterns. Let's go down here. First, powered flight. So powered flight is where the bird flaps, and their downstroke is a strong downstroke, and the lifts up stroke, the uplifting stroke in their forearm is quick and a backward flap. And so this gives them more power. It's a flapping downstroke and that lifting upstroke. Usually larger birds have slower flaps, and the hummingbird, of course, flaps 50 times per second. And a herring would flap like 2 times per second. A heron is very slow, big bird, 1, 2, and then a hummingbird is ding, 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 50 times per second. So the powered birds are the flapping birds. So generally the larger the bird, the slower it flaps its wings. Okay, gliding. So we talked about powered flapping. Now we're going to talk about gliding like the albatross there. The gliding is like this toboggan downhill, like you're getting on a toboggan and you're jumping and you're just gliding all the way downhill. That's that glide. The giant albatross has a 12-foot wingspan and it glides for hours. And then we have the lighter birds that have large wings. They glide more slowly. And then these heavy birds with the small wings can get greater speeds going. So it's very important for a good glider so they can go a longer distance and basically lose the smallest height, so they can stay up there pretty high when they glide. And so shearwaters that's a type of bird, can glide 10 foot per second. Altitude, sustained flight depends on the motion in the crests of it, but that gliding motion is pretty spectacular. So let's go on. That's the gliding. We're going to go on to the next. Shearwaters and albatrosses. Those are the kind of that glide when you see gliding over waters, looking for fish. So, and then down here we have the soaring flight. The soaring flight, we have a picture of an osprey here, but the soarers are like buzzards. That's, hawks. Buzzards are vultures, right? Hawks and eagles. And soaring is where they circle around. You'll see them circling around at great heights. And this circling, as they circle down and they circle up, they're riding these thermal air currents. And they have soft tips. They're pointed like fingers almost. And they call this the soft tips with slotting of their soft tips at the end. You see where the slotted feathers are right here. And this slotting helps with the soft tips pointing like to prevent turbulence and also to reduce speed to land. They need these slotted fingers. They're like little fingers at the end. And this gives them minimal energy so they can soar. Soaring, of course, you think of soaring is soaring in these great gigantic circles. Just remember that. So going on to, again, the hummingbird. And the hummingbird's special flight pattern is, of course, like a helicopter. And it's hovering, and that makes them very acrobatic. They're like acrobats in the air. These include not only hummingbirds, but swifts and skylarks. And you'll see these, and the way they do is they look more, they can just go straight up like a helicopter goes straight up in the air, so. Let's see, they're almost like the hummingbird has these little elbows that hint like a dragonfly. And so they tilt and they have this rowing motion, like row back and forth, row back and forth, row back and forth, like that. And that keeps them up in the air, kind of like a dragonfly or an insect. And this is not fully understood. A lot of people think, what in the world? How does a hummingbird? So even the scientists can't totally, even though we have helicopters now that kind of copy this flight, it's still not known how the hummingbird and how some of these birds can do these as they hover up in the air. And so they fly using their hands. This is at the end. It says here, they fly with hands, almost exclusively using the tips of their hands to do this rowing motion, right? And their shoulder joint is very motile, as you can see there. So those are the flights. And remember that there's a powered flight, and then there's gliding flight, and there's soaring flight. And here's the soaring flight, as you see here in this, we saw that. And on to the soarers. Those are the soarers. And these are the gliders. So we have gliders. We have powered flight first, very powerful flaps. And then we have the powered flight. We have gliding, soaring, and then the hovering or the special flight. So there's a glider. So that's it. And we'll go on to now, there are different, as we do the different anatomy and getting into the different systems, similar to the anatomy of a human being, but we're going to do the anatomy of a bird. So how fun.